Hey, it's Joe Farrow with Geek Toolkit, and welcome back. We're going to talk about security camera lingo in this episode. This is all the stuff we're going to go over in this episode. We're going to talk about codecs, we're going to talk about protocols, we'll talk about command line tools, we'll talk about the forum and what that means, ONVIF, we'll talk about what an NVR is, and then at the end we're going to have some fun. We're going to talk about some of the AI stuff that's coming out, well, actually that is out and has been out to make these cameras smarter. And keep in mind, this is all about local stuff, not necessarily cloud-based stuff. So things that you can install at home and get some processing going on these cameras. So real quick, before we get into it, let's split out the two types of categories so I can explain what we're going to talk about in this video. Proprietary cameras are not the focus of this video, but they're good to understand what they are. Basically, it's a cloud business model. And what that means is they're going to sell you cameras, and then they're going to have a upsell for cloud business where they can do storage or AI and so on. Ring is really great at this. They have a Ring Pro camera where you can actually set up motion alerts, but then they have, if you want to actually review the video, you have to pay them to have their cloud storage. Arlo is one where they'll do motion alerts on pixel-based things, and we'll talk about that a little bit later. But if you want to do something smart, like, detect if a person or a car is on the camera and only alert you then versus when the leaves blow, then of course you pay more for that, or if you pay more for more than 5 cameras. So these are all subscription upsells that are available. The cameras we're going to talk about in this video are what I call standards based. They use things like the ONVIF forum, they use RTSP. And what that means is that you kind of get to pick what kind of software you want to, or hardware, to actually view these cameras, record these cameras, stream, and so on. You can do all sorts of stuff, and a lot of it, you don't have to have the camera go off of your premises. And what I mean by that is the video never goes to the cloud. It never goes to the internet. It stays local. If you have a baby monitor and you don't want your kid broadcast out to the internet, that's great. These are the kind of cameras you would get for that. The other thing is, for tinkerers and geeks, you've got access to using like VLC or FFmpeg to transcode the video. We'll talk about what that is. You can get hardware NVRs, software NVRs. There's all sorts of stuff. Home automation hubs will just basically hook into the protocols, and that allows you to use them. So you get a lot of flexibility with these, and that's what excites me, and that's what we're going to talk about in this video. So let's get to it. The first thing we need to talk about is how to get the video signal to and from the camera. And what I mean to the camera is, the camera is actually like a little smart computer. It actually has a CPU, memory, and a little OS on it. So what you're going to do is you power up the camera and then you send signals to it to control it. We'll talk about that more when we get to RTSP. The way you can do this is you can either plug it in the wall, standard 12 volt wall wart plug or whatever, or you can actually send it over your Ethernet connection, which you then end up with a hardwired network connection, and you send power to it at the same time. This is called POE, or power over Ethernet. What's cool about this that I didn't realize until I got into this is I thought you had to have an entire network set up for POE, and that's not true at all. You can actually have your standard wired network, and then at the very end, right where you're about to plug in the camera, you can get what's called an injector, and that little device in the lower right is what they look like. Your network that plugs in the LAN side, and then the PoE side has a network cable that goes out to the camera. Boom, you're up and running. The back of it has a power plug that you plug into the wall, and that's how it gets power. Now, because you're running a lot lower voltage than in wall, you don't have to run it in conduit. You don't have to turn your power off. You don't have to do Romex or any of that craziness. It's really cheap. You run a network cable and you're good to go. Because it's a wired one, they can't jam your Wi-Fi and take your cameras down or anything like that, which is what's called a DOF attack. You're going to get a bit better latency and a lot better quality off these cameras. And you don't have to worry about, the one thing when I bought a Wi-Fi camera and I had it outside, my Wi-Fi signal wasn't really optimized to go outside. And so I found myself trying to move my routers around or looking at buying bigger and better routers to try to get my Wi-Fi signal to go further, which really I would rather not do, honestly. But that's what you have to do if you're going to try to get Wi-Fi cameras that are outside to light up. So if you don't have good signal strength, you're going to have a slow connection. You're going to have a crappier image come back. With Ethernet, because you have a hardwired connection, you have a much more reliable connection. One other cool thing about PoE is there are PoE Raspberry Pis, so you can actually power a Raspberry Pi over PoE as well. So, just getting into the PoE technology can be a lot of fun for just being a geek with technology. All right, let's talk about the next thing here. This is what the visual of what we're going to talk about next. The ONVIF is a forum. We're going to talk about that in the next slide, but it is over all of this. And it actually covers a lot more than just the video of a security camera. It covers the audio, the alarms, and so on. We'll talk about that. RTSP is what's called a signaling protocol. And it's on the left-hand side here because it's not actually a video transport. RTSP is a protocol that will tell the camera to play and reveal its underlying stream. MP4 is what's called a container. It's not a codec. The inside of an MP4 can be very different. So you can have an H.264 based MP4 and H.265 based MP4. Those are the codecs underneath. And we're going to talk about what all of these are, but this is the layering of how this works together. ONVIF, this is what it stands for. Now, what ONVIF is a forum. And what happens with a forum is a bunch of companies get together and they decide we're going to make stuff that works together with each other's stuff. This is a very different approach than the proprietary approach we talked about at the beginning. The reason that you would do this is maybe a camera manufacturer doesn't feel like making software and the NVR system and so on. They want to make a really good camera, but they want to make sure their camera works with other people's hardware, like their NVRs. So by having this standard, they make sure that they can communicate together. Now, the ONVIF does all sorts of stuff to make sure that all sorts of features work together. So things like the alarms, the PTZ, which is pan, tilt, and zoom. Those are cameras that actually move. This would allow somebody to have a recorder with buttons on it, and when they hit the up on the button, it will actually move the camera accordingly and do it in a correct way. So this is all possible because of this forum. Now, the way this forum identifies their cameras is they do what's called a profile. Profile S came out in 2011, and it has its certain feature set. So if a camera says, I support Profile S, it supports, its features that it exposes are matching that. And if something else supports Profile S, they should work together. The reason this is important from a home automation standpoint is, for example, the ONVIF support in Home Assistant is at Profile S support level. So that means that if you have a pan, tilt, and zoom camera, your home automation system should be able to control it. Profile T was a bit later. It adds other things, or it adds newer things on it. And there's a whole bunch of profiles. And I just wanted to give you an example that it's not just the video signal. It's everything from audio to the alarms to how it compresses to how it secures the transport, all sorts of stuff. So that's what ONVIF is. Now, RTSP is separate from ONVIF. If something is ONVIF based, it probably uses RTSP underneath it. But this is a protocol that is very important. And there are cameras that are RTSP capable that are not ONVIF. RTSP, though, is something that if your camera supports that, it's going to be compatible with a lot of different tools, including things like VLC. Now, they call it a VCR-like functionality, but it's really, I'm going to say a Blu-ray because I don't know how many people I'm watching know what a VCR is anymore. But the thing about this protocol is this protocol controls the camera remotely. The cameras themselves are little computers. The other thing about RTSP is NVR hardware and software. This is how that will be able to control it. Now, not all RTSP cameras are compatible with home automation systems. For instance, Arlo, if you search it for it, you can find out Arlo cameras do have RTSP, but they encrypted it. And this is, again, about kind of locking into their system and protecting it. But for a home automation person, this is a bit brutal because it requires you to either reverse engineer it or find somebody else that has to actually communicate with the camera and control it. Okay, FFmpeg is something that's mentioned a lot, and there's a lot of people that understand what this is, but if you don't, it might be a little bit confusing about why you see it so much in home automation. FFmpeg is an open source library that does a ton of stuff for processing video streams. It can actually just open up an RTSP stream and get the underlying codec and then actually play it back. It can transcode it, it can rebroadcast it, and so on. It's cross-platform, so you'll see it mentioned on Raspberry Pis, on Linux, on Windows, and so on. There's a command line based tool, but because it's open source, a lot of things that want to do video processing will use FFmpeg. When I talk about Home Assistant in my next video, there's an FFmpeg add-on for it, or basically a component. And that's why, is because Home Assistant can then use that to actually stream the video. Okay, so underneath this, when the camera, you send out an RTSP command and you get back a stream, an MP4 stream, that stream is encoded. It's going to be in a codec of like an H.264 or an H.265. H.265 is a newer codec. It's mainly came about with 4K. It's much more efficient than H.264. It's about 30 to 50% smaller. What a codec is basically takes a large file, like a video file, and makes it smaller. H.264 has been around a while, and as such, it actually has hardware that can help accelerate that encoding. H.265 hardware acceleration is still fairly new. The reason I say all this is if you're running a home automation system off of something like a Raspberry Pi, you're probably not going to have H.265 hardware support for either playback or encoding, whereas H.264, you can get a bit away with it. Now, AVC, the advanced video coding, the reason I mention that is sometimes a camera won't say if it's H.264 or H.265, but it will say if it's AVC or HEVC. Very important to know. When I talk about Home Assistant, my next video, I'll talk about, its support is only H.264. The reason this is important is if you get a 4K camera and it supports H.265, you're going to have a hard time getting it to integrate directly. So that brings us to this slide and why 4MP and 5MP cameras are so important. If you look at TV technologies, you had 720p, 1080p, and 4K. If you look at camera, like cell phone cameras and so on, you'll have like 4 megapixel, 5 megapixel cameras back in the day. Those were resolutions that were between a 1080p and a 4K resolution. Now, if you combine this slide with the last one, you'll start to understand why this is so important. A 4K camera is most likely H.265 based. And again, the hardware encoding and decoding for that is going to be a little bit harder to find, a bit more expensive, and take more, basically more oomph. A 5 megapixel camera gets you a lot better quality than 1080p. Not quite 4K, but it's still H.264 encoded. So you get all of the benefits of having all of these devices that can support this with the H.264 codec. Now I want to talk about a little bit about that P on the end. Why is it a 720p or a 1080p? This means progressive. Back in the day, you had interlaced TVs, and what they would do is they would show something for, let's say, 30 frames at every other line, and then the next frame would be all of the opposite lines, and they would interlace those two. And if it showed them at 60 frames a second, your perception would be that everything would be there. Progressive shows everything in one frame. So while you might have a 60 frame per second interlaced, you only need 30 frames of progressive to get the same amount of data, and you get it a bit sharper when you're dealing with motion. You don't get any jitter because it's all shown every frame. So all of these Ps like 1080p, 720p, and so on, they're all progressive, and that's what that means. I just wanted to explain that because I think people see the P and the meaning is almost lost now because a lot of people don't remember interlaced. So that's what that is. Okay, so what the heck is an NVR? It's a network video recorder. It can be a hardware device or a software device. A hardware device in the lower right there, that's a network video recorder. You can see all the ports where you'd plug your cameras in on the network side, and then you can have your monitor out on the VGA port on there. And the nice thing about that is you've got like a little hardware device that will control everything, typically plug in a hard drive, and it can record as you wish. The upper right hand corner, that's a software called Blue Iris, and this is a software system that it runs on Windows. I think it's about $60 or so. And it is a software version. Now, the nice thing about this is all of these NVRs I mentioned, if you have an RTSP based camera, you can choose which NVR you want. MotionEye is a Linux based free one. Shinobi, I believe, is also free. So you've got these options of, do I want to pay for commercial software? Which one do I like best? Which one does what I want? And that's just really cool to have those options. Now, NVRs are cool. Like if you buy this is a Reolink, which is based on the Reolink cameras. If you buy a Reolink camera, then their NVR automatically works with their cameras. It can auto detect them on the network. And it's just really nice and fancy. You can see I've got my backyard on the left. I've got my office on the right there, just to kind of show you a little bit of the quality. And you can do all sorts of different layouts. You can do detection on motion. If you're running a software NVR, you can record directly to your hard disk that's running the application. You can set up email notifications on motion, stuff like that. What I call multi-view, this is where you've got like the little grid going on. You can also listen to the cameras, and a lot of cameras have two-way audio, so you can actually talk to your microphone and have it go out of where the camera is at a little speaker on the camera. There's also cell phone NVRs as well. So Raylink makes software for desktop and a phone, and you'll see this a lot with NVR software. Okay, so let's talk about motion detection, because there's a number of different techniques for doing motion detection, and it's important to know what your camera supports and what your software supports. Pixel-based motion detection means that if any of the dots or pixels on the screen change frame to frame, then that will trigger motion detection. Now there can be a threshold that says, it has to be this many pixels or whatever, but it's not super smart. I'll give you a great example. When the camera goes from nighttime mode to daytime mode, because the light outside has changed, that's typically enough to trigger pixel-based motion detection and give you an alert saying, I see motion. And if you looked at the camera, you'll see nothing happen other than maybe it's daylight. The other thing about pixel-based motion detection, if you have like a Ring camera and there's a car driving by, it's going to go off all the time. There's a threshold for sensitivity, but you want to be careful there, because if you set the threshold too high, then it won't detect things that you do care about. Now there's what's called mask options, and the Ring and Ring Pro is a great example of this. If you bought the Ring camera, it didn't have mask options, so you're basically at the mercy of any motion. And if you got the nice camera, you could mask it out. And that's what I'm showing in the lower right-hand corner. What you can do is basically draw on the screen and say, I don't care about motion in this red area here. I only care about motion to the left. So you can see I have like a staircase to the left of that red. And what I'm saying is, like, don't worry about that tree over there that's moving in the wind all the time. But if somebody walks in that staircase, I definitely want to get alerted. So that's what masking is. It's basically where you block out where you don't care about motion. It's great for things like trees or whatever that are constantly moving, but it still typically doesn't get you where you want to be. Now, finally, the super cool thing about home automation systems is a lot of them can plug into AI-based systems. And some of the NVRs, such as Blue Iris, can do this as well. An artificial intelligence-based system actually analyzes the image, applies an algorithm, and then comes back and says, what do I see in this image? And that used to be just, do I see a human or not? But now it's gotten a lot further, and we're going to go into that in the next slide and have a lot of fun with that. This is the most effective way to get a motion alert. This is really what you want. Now, Arlo supports this. If you pay them, they'll do things like they'll tell you if it's a person, car, or dog. But again, that goes out to the cloud. It comes back. There's a lot of latency with that. What I'm going to talk about is local ones that you can run in your home network. So I'm calling this post-processing, and this is where you take your home security feed and you're able to feed it to something else. Now, if you have something like Home Assistant, it's really easy to plug a lot of these in. Some of those NVRs plug into these and so on. And then you can also, if you're a coder or a developer, you can develop your own, and here's some frameworks to work off of. I'm going to talk about Deepstack. Actually, these three screens on the right are using software called Deepstack AI. And what's cool about Deepstack is you run it locally on your home network. So all of this all of the detection you're seeing on the right was done without going to the cloud, without going to a pay service. It's basically local. As long as it's not commercial, it's free. You've got other ones like YOLO is open source, I believe. Sentry AI is actually a plugin for Blue Iris. I think that's actually a cloud-based pay one. Motion AI is hooks into Home Assistant. I believe that might even be based on YOLO, and so on. There are a ton of them. And what's cool about this is some of them are facial recognition. Facial recognition ones will try to identify who the person is, and some of these are object recognition. Object recognition is going to do things like what you're seeing on the right. Now let's break this down. In the top right hand corner, you see that it sees 3 people and it has a percentage. A lot of these AI systems will give you what percent does it think it's right on this. And typically if it's over like 70 or 80, it's pretty well on, but you also see sometimes it goes down to 40. Now, the top one is 3 people. It sees all 3. The next one down is really cool because not only does it see the cars, and it saw all of the cars, even the one in the upper right that's like, halfway off the screen, but then it also sees the motorcycle and it sees the person on the motorcycle, which is really powerful. It just shows how well these things work. In the lower right, it actually detected not only 2 people, but it detected the horse on the right. Now this is interesting because it doesn't detect the horse in the background. It missed that one, but it did get the thing on the right is a horse. And this is, again, the power of these AI systems. Now let's have some fun with this. So I got really excited because I was like, wow, this thing detects people. Let's throw some test cases at it and have some fun and geek out a little bit too. So I threw the N7 crew in the upper left-hand corner. I was like, well, does it detect aliens? Yep, detects aliens, no problem. I threw the next generation crew at it in the middle center there. And the interesting thing about this, that resolution on that image is really low, and it didn't matter, it detected it just fine. Turns out that these AI systems are actually expecting very low res images and are very good at analyzing them. It even caught Wesley there in the back left. I threw a cartoon at it, threw Dragon Ball at it, and it detected their hair as bananas. These things are not meant for cartoons, but I thought it was interesting and just kind of seeing where the limits were. Lower left, I wanted to know if people with masks worked, right? So I threw Freddy versus Jason there. And the interesting thing about Jason, not only did it detect him, it didn't care about the mask at all, but his arm is kind of behind him. Like even looking at that and the way the colors are, it's kind of hard to see him as a person. I could see like an image algorithm just thinking that's a blob there, but it detected him just fine. And these yellow bounding boxes show the height and the width. It really nailed him. The Scooby-Doo, of course, you know, that was another cartoon one I had thrown at it and it failed. And I was like, okay, I get it. It's not optimized around cartoons. What about the movie? And this one is interesting. The person that it shows in the background at 40.1%, there is a person back there. Had to blow up the image to find him. The person to the left of Sarah Michelle Gellar is not, that's obviously not a person there. So it had a miss there. The other one is to the right of Sarah Michelle Gellar. There's a face in the background. You can see clearly that it missed. So, you know, it wasn't 100%, but that's okay. It's made for security cameras. I was just kind of testing it and having some fun here. Okay, so I want to wrap this up and just say that I was going to do all of this as part of a Home Assistant video and realized, you know, you can see even on this video, it got quite long. I do think this is valuable data, though. It's stuff that I had to research and I wish I knew before I picked out some cameras. I'm really glad to know it for picking out my next cameras. In the next video, I'm going to talk about how to get a real-link camera and basically cameras in general into Home Assistant. And I'll refer back to this video so that I don't have to go over all this again. But if you're not looking to hook up something to home automation and you're just wanting to learn about security cameras in general, hopefully this was helpful for you. If it was, let me know in the comments below, give me a like, and share it out to others that are trying to learn this stuff. I really do this to have other people learn from it, so that's great for me. And I want to thank you. If you have any questions, ask them in the comments below. I try to answer every comment I can. Thanks a bunch. I'm Joe Farrow with Geek Toolkit. Until next time, I'll see you soon.